Thank you for joining us today. We are pleased to present to you the third live Sentinel Hub webinar. The Sentinel Hub is a cloud API for satellite imagery operated by Synergize with headquarters in Ljubljana, Slovenia. We will start with the opening presentation by my teammate Marian Sterk. Afterwards, we will give the floor to Monia Shebela, who will dive deeper into the Sentinel Hub Process API, the topic of today's webinar. Today there are also a few of our team members present with us, so we will try to make sure to answer as many of your questions as possible. And now I'm giving the word to Monia to guide us through the agenda of today's webinar.
Hi everyone. As Sabina mentioned, my colleague Marian is going to first tell you why you would want to use the Process API and what the RESTful APIs are. And then we're going to have three general parts. In the first one, we're going to take a look at how you can run a process request in Postman, how to authenticate them, and then also how to use a request builder, a very friendly, user-friendly user interface to construct your own requests. In the second part, we are going to dive deeper into the API, into the structure of the process requests. We're going to take a look at the API reference to understand what is actually going on. And we're going to take a look at a couple of examples from our documentation. We're going to run them and try to analyze what are the differences between them in the process API structure. The part 3 is going to be dedicated to Python. First, we're going to take a look at the introductory notebook in how to work with Process API in Python. And then we are going to take a look at how you can use Request Builder to grab any Process API request and run it in Python. One of those is going to be a datafusion, and I think this is going to be a very exciting part. I am giving the word now to Marian.
Thank you, Monia. So, just a quick general intro on what is the difference between the two APIs. Let us first remember from the previous webinars what the OGC API looks like. So you can use it to get processed data over the HTTP protocol from Sentinel Hub in the same way you use, for example, web browser to get web pages. This means that you can simply also copy this URL of the request into browser and you can get the data immediately. And since this uses the OGC standards, you can also use the data with any OGC compliant software such as QuantumGIS. However, to specify what data exactly you want, how you want it processed, and so on, you have to prepare some things in advance, marked in the red color in the above. So you can't do it everything ad hoc. And for more complex requests, this quickly gets out of hand. And also, since the OGC standard supports just a fixed set of features, you can't do everything with this API. Now, what is REST? REST is a style of APIs that is very popular nowadays for various web services. And REST APIs don't just use GET requests, but also others. And the Sentinel Hub Process API is used so not to get data, but to post a request for Sentinel Hub to process data for you. This is not just a different naming. The difference is that the URL is always the same, but your request contains also the content. And the content of the request tells the service all the detail about what data you want and how you want them processed. So you can specify everything at once. You don't need to prepare anything in advance. And you can also do much more. For example, you can retrieve rastered results and metadata at the same time. However, as this is not a GET request, you can't use it directly in the web browser. You have to use tools such as Postman or Python, as you will be able to see now. So this is just the general. Now for everything else, I'm giving the word back to Monia.
Yeah, we're going to go to the Sentinel Hub documentation first. And to go there, you just write Sentinel Hub documentation, and then this link, the sentinelhub.com is our website, and then this one that starts with the docs is our technical documentation. And here you can find all the information you need about the process API. If we go under data, Sentinel-2 L1C examples, we can see some examples here, and this is how the process API request looks like. This is in a curl format, and immediately you can see, you can recognize some information. You can see the bounding box over here. You can see the data collection over here, then the time range, width and height of the image, and then over here we have the eval script. But how this is all structured, what all of these parentheses mean, and so on, we're going to take a look at this in detail later. But for now, we are going to grab this, and we are going to go to Postman, and we're going to import this request by clicking on this import button, then clicking on raw text, copy pasting it in. Then I'm going to, we already see here that we're going to need an access token, and we will see shortly what this means. I will click on continue to import this request and import again. And now this is I can immediately see the post is set up over here, and then this is the URL of our request. So this last part, API v1 and process tells the system that we're making a process API request. The sentinelhub.com is always there, and the services is on which deployment this is. We're going to also take a look at this a bit more later. If I click on body here, I can see that this is my request, the request body over here, and I have the eval script here. The Postman has nicely imported this for me. I'm going to click send, and as expected, I got an error that we are unauthorized. This is the 401 error, and all the errors that are 400 and more means that the issue is most likely on your side, while if it was 500 or more, then it is probably on service side. It says that we need to provide an authorization bearer access token. Now, when we were working with the OGC, we also had to provide the instance ID to tell the system who we are. But over here, we are going to have to get the access token. To do so, we will go here under the tab Authentication under API Overview. Here you have all the information about it. You have a documentation on how to authenticate in curl, Postman, Python, and JavaScript. What we actually need to authenticate is the access token, and we get that by providing the Postman and also Python our ID and the secret. We will go into the dashboard, and in dashboard we first have to be logged in, and then we go under our user settings. And over here, you can see OAuth clients. So we need to create an OAuth client. This is very easy to do. You just click on this green button over here, and then you can name your client whatever you want, such as, for example, my client. Keep the client credentials on. Click Create Client, and now you will see this large secret ID displayed. This secret ID is going to only be presented to you at this point in time, and then it is going to vanish forever. So you should copy this, and you can save it on your computer, as we're going to do right now, because we're also not only going to need it now for the Postman authentication, but also later for Python. I will copy this and then close. Then I'm going to go on my desktop, and I will just create a text document where I'm going to store it. Okay. Now back to our dashboard. As soon as we close that dialog window, we can see our OAuth client over here, and we can see the ID displayed here. So the client ID is not going to go anywhere. It will stay here with you forever, so you do not need to especially save it. I will now copy this client ID, and I will go into Postman to do the authentication. To do so, click on this authorization tab over here, and then you have multiple options. We're going to take a look at the default one later, but what we want is an OAuth client. Yeah, and over here we are going to have to input all the information. So in this window here, our access token is going to be displayed. The header prefix bearer is okay. Token name, we can leave it to be Postman. Client credentials is the correct thing to leave here. And then we are going to need the access token URL. You see here already displayed how it's supposed to look like, but we're going to go to our documentation, and we're going to grab it over here. So this is the endpoint for requesting tokens, and we're going to pop it in here. I have now lost my copied ID because I copied that other one, but I will just do it again. And then I will insert the client ID over here. Then to open the client secret, I will go into my notepad, copy paste it. Okay, the scope can be empty, and send as basic OAuth header is okay. I will now click on get new access token. Authentication is complete. I will click proceed, and this long ID over here is actually now an access token. The number down here says in what time it is going to expire. This is in seconds, and it is about 1 hour. So when the access token expires, you are just going to have to request it again. That doesn't mean that you're going to have to import your ID again. Just click the request token again. Then we click on use token, and the access token has been added over here. Then we can then we are authorized, and we can click on send again, and we now got an image. So this is the request that we have sent successfully. Now let's take a look at how we can do this same thing in our request builder. In request builder, you need to be logged in. In request builder, you do not need to provide, you do not need to do the authentication as we did in Postman with the ID and the secret, because it reads this information from you being logged in. It reads it from the dashboard. Now we're going to go to examples, and we are going to grab this curl request. And we're going to go down here in our request preview, pop it in, click parse request. And this is now a really wonderful thing about request builder. You can put any request in here, and it will update all the user interface so that you can see what is actually happening in that request. If we click send request, we're going to get an image. Now let's take a look a little bit of what all these parameters are and how you can use the request builder. So we are in the process tab on here on the left because we are using the process API. There are, as you can see, also other options. You can choose the data source. This specific request is using the Sentinel-2 L1C data collection. You can see some advanced options over here. As you can see, this is what is currently selected. This is the time range is selected, the width and height of an image, the JPEG format is selected, and this is the bounding box. You can see the coordinates here, and you can also choose between two coordinate systems that will automatically update your coordinates. This is the eval script, and everything that you change in the user interface automatically changes in your request. So if I would click on PNG over here, this would now update into PNG over here. I am now going to make a request using Sentinel-1 to show you. I want to choose an area in Papua New Guinea where there are some interesting volcanoes over here. I am just going to draw the bounding box. The coordinates are updated. I don't have to copy paste anything because it is already updated over here. So let's say that we want the most recent mosaicing order. We do not need upsampling or downsampling. Let's choose a high resolution. Acquisition mode can be any, polarization can be any, so that we'll be able to construct a script. Let's choose an ascending orbit direction. Leave the backscattering coefficient to 1 and enable the orthorectify with, for example, the 30-meter Copernicus DEM. Let's leave the time range as it is. If we wanted to choose it, that would be very simple. These green circles show you on which dates the images are actually available. Let's change the height to 1000. As you can see, the ratio is kept so that it keeps the ratio of your bounding box. It doesn't stretch it. And we are going to choose the TIFF. Now the TIFF by default is going to be in integer 8 because the sample type is going to be auto. If you want to change this, you have to do this in the eval script. For this, read our documentation on the eval script. We're going to take a look later at what the identifier does. And now let's take a look at this request just quickly. We can see the bounding box here. The data collection is now Sentinel-1. The time range, mosaicing order is added as most recent, resolution as high, orbit direction as ascending. The DEM instance is selected as Copernicus and orthorectify as true. This is our size, the TIFF image, and down here we have an eval script. Let's make a little bit of more interesting eval script, like for example 3 times VH, which is larger than 0.5, VV, and VH times 8. It is already updated, which is wonderful, and now we can send this request. We can download the response because it is a TIFF image, it didn't display it immediately. And then if we open it, we're going to see our Sentinel-1 image of this area. Okay, so the next thing we're going to do, if we take a look at the agenda, we have now finished this first part. We're now going to continue with taking a look at the structure of the process API, and then we are going to take a look at some examples. To find the API reference, you need to be in our documentation, and you go down to the bottom, and here you can see the API reference button, which will send you to this website, which is a very handy tool for referencing the API requests. Here on the left, we're going to search for Sentinel Hub API process. And we can see this area here is what is interesting to us. We can see that the request is constructed of 3 main parts: input, output, and the eval script. The input and the eval script are required. And if we expand this arrow over here, we're going to see that bounds and data, which are also required, are nested under the input. And now here on the right, you have a very handy example so that you can see how this structure translates to the actual request. As you can see, all of these parameters are in brackets, and then when something is nested, it is contained in the curly brackets. When something is an array, such as for example data, it is also contained in square brackets, and then the value of the parameter is separated with the colon. And then you have this nesting structure which can go deeper and deeper, so that you have all of it constructed. Now I have prepared a request over here. I'm going to open it side by side so that we can see both. This is the request that we can just quickly run it in our request builder to see what it returns. Let's just select body over here. And now send it. And this is the area that we have. It's Sentinel-2 L1C with least cloud coverage, PNG format, and so on. Okay, now back to the API reference. So let's start at the beginning. So first, we have this all contained in curly brackets because this is a request and everything is contained in it. And then we have input over here, and then it nests itself into bounds and data. And it has curly brackets over here, and then bounds continue into the bounding box over here, which is an array of numbers. And then we could also choose the geometry instead of the bounding box, which would have a different structure. And then we also have some properties over here. We could add the CRS over here if we wanted. And in fact, let's try to do so. So we have this bounding box over here, and we know that the properties belong right after the bounding box. So you would then add it over here as properties. And then you would use curly brackets, and then you would again nest in the CRS. And then to see which CRS are available, we could click on this link, and then here you have all the list. And for example, you would just grab this URL, which would request then this CRS84 coordinate system, pop it in, and this would then add it to you. Okay, so this concludes the bounds. Let's continue with the data. So as you can see, data is an array of these values. We have the type, which data collection you are using. When you click on the different options over here, you are presented with what you are supposed to input. For example, if you were using DEM, you would use a DAM here. Then you have an identifier. You have a data filter, which is very useful because here you have a time range, which has in itself nested from and to. Each of them is a date, and this is the format of it. First, there is a date, and then you have the hour specifically if you would want to. Then in the same level as the time range, we have mosaicing order with all of these options, but you can request least cloud coverage, the image that was acquired least recently, most recently, and such. And also the parameter maximum cloud coverage, which we can add right now. We just write it under the mosaicing order. As you can see, it is in the same level. Just write the max cloud coverage. And it has to be a number between 0 and 20. Let's say max cloud coverage should be 20%. Down here we have processing, which includes upsampling and downsampling if we wanted to use this. But we can now close this. And we had finished with the input. We have covered everything. And then we have the output over here, right after the whole input is closed. And it includes width or height. So you can either choose between having width and height, or you can have resolution X and resolution Y, depending on what you want. Here under responses, this is also very useful because very often we want to specify the format for our image. Here we have the identifier again, and then format is again nested under type, as you can see here, format and then type. And then let's say that we want image diff, we just select this option, and immediately we can see that we're supposed to put this in. And now this request is going to give us a TIFF instead of a PNG. At the bottom there we have the eval script in the same level as the output and input, and here it is just written in brackets. I am not going to go into eval scripts right now because for this you should watch our first webinar on custom scripts. So I hope this gives you a little bit of a better understanding of how this is all structured. It's all about the nesting of these parameters under the parameters using the correct brackets. And in order not to make mistakes, it is the best for you to copy already existing requests and then edit them as you need, or to use the request builder and user interface, because then you can't really make a mistake. Okay, the next thing we're going to do, now that we have hopefully a little bit of an understanding of the structure, is check out what all of these different ways of sending the process API are. So what we see here in this payload option, it's called a body. These are just different ways in which you can send the request. It can have different formats and it can be sent in different clients. So if we take a look at the request builder, over here we have the request in body, which is very easy to read because it doesn't have any it's a bit easier to read it, for example, curl, but each of them has its own use. Now this one has an eval script already embedded into it. So this is a single body request, which means that if you are going to import this into process API request, you would have to check the rob. I'm going to show this all to you later so that I don't just confuse you right now. If we take a look at the curl over here, this is again another way of sending this. These H's are just headers, and then again it is a similar structure and the eval script over here. Then we also have in JavaScript form and the Python form. These are just two different clients in which we can use these requests, and we're going to take a look at this Python form later. So if we go back over here, if we take a look at this multi-part curl, this is actually the same thing. This is actually the same thing as we have in our website, our examples, and it separates the requests into a request and an eval script, so that in Postman you can then go under form data and you can have them separated. While if you would, for example, import a request from the request builder directly, which uses this in a single body, then you would have to in Postman you would have to go over here, body under raw, and then everything would be over here. So this is mostly useful for developers and programmers, but still so that you have a little bit of an understanding what all of this is. Okay, next we're going to take a look at the examples. And as you can see, we have quite a lot of examples prepared for you here. And this is just for the Sentinel-2 L1C. This is so for most of these data sets that we have available. Otherwise, we are going to add in the future. And we have prepared a Postman collection with examples for you. We're going to download this, and it is going to open in a window like that. What you need to do is save it to your machine, for example, on the desktop. And then you go to Postman, and we are now going to import. Click on import, upload file, and then just grab it from the desktop and import it. You can see the format is Postman collection, import as collection, and here it goes. Now, these are all the requests, and if you compare them to these titles, you're going to see that these are the same examples. These are the same examples. We have true color, and then we have true color with a resolution. There you go, true color with a resolution. Now it would be very annoying if we had to authorize each of these requests separately. So this is why collections are extremely useful. You can authorize the whole collection, and then each of these are going to inherit the authorization from the collection. But given that under authorization tab, you have inherit of from parent selected. Let's go into edit under the collection, click on authorization, choose an OAuth 2, and then we already have it saved in here from before, and we can now choose get access token, use this token, and update. So now all of these examples are supposed to work if we hopefully did everything correctly. So if I just send this, there I get an image. Now we're going to jump between two a little bit and take a look at what all of this is. So the first one is the true color. It only has the CRS over here. It has the bounding box setup, the collection, the time range, width and height. These are the minimum requirements that you need to have. And then we have the eval script over here, which returns a true color image. Then if we take a look at the second one, the only difference is that instead of width and height, it uses resolution. Then the next one, let's take a look at this one. This is a true color and metadata. And over here we are, this is now what we were talking about, the parameter, we're talking about the parameter identifier in the API, in the API reference. So here it comes into play. If you want to, for example, return several different separate outputs, you would then have different identifiers. So you would have multiple responses, which would each have its own identifier, and it can have its own format, and it can be named anything. But the first one is usually by default named default. So we are here going to return. The result, which is going to have a TIFF, and it is also going to have a user data JSON information. And this also has to be reflected in the eval script, where we are also returning the output metadata and also the eval script over here. So let's take a look at this one. NDVI is a JPEG with bounds given as polygon. So here, instead of the bounding box, a polygon is used. And as you can see, it's a little bit different. We have the geometry, then we have type, we have polygon, and then we have the coordinates, and the coordinates can be as many as you like. There are some upper limits though. And this is all, everyone is a point of X and Y coordinates. And then we have the NDVI calculated and returned as a JPEG file at the end. Now let's try to run this one. Okay, NDVI is JPEG image with bound given the polygon over here. Send. And this is the polygon that has been made, and the NDVI is calculated in between. You can also see the body of our request here, and edit the eval script over here. Okay, so there is also over here an option to return a geotiff, which has all of the bands embedded inside, so that you can then open this diff in QGIS and explore all the different bands. As you can see, there are a lot of examples. They were prepared to cover as wide of possibilities as wide as possible, so that you can find something that suits your needs and then maybe just edit it a little bit. Okay, Now, the next one that we're going to take a look at is the Sentinel-2 L1C, and we are going to download this collection again. Save as. Okay. We're going to import it. S3 L1C, open, import. Okay, so now we have also this one. And what I wanted to show you over here is actually the endpoint. As you can see over here, we have creodias.sentinelhub.com, while with the Sentinel-2 examples, we had services.sentinelhub.com. Now, this is very important that you know from which endpoint you are requesting your data, because it depends on where the data is actually stored. And to figure out everything about this, you just go under our documentation on data, and then you have each deployment and which data it holds. So for Sentinel-2 L1C, you can see the endpoint is services. And then if you scroll down, if you wanted to use Lancet 8, it would be on services US West 2 endpoint. And then Creodias has the Sentinel-3 L1C, and you can see the endpoint over here. So this is you just have to replace the URL. So if you take a look at the L1C examples, it's a similar selection. So we also have a multi-band geotiff. So you can see the TIFF selected over here under type, a JPEG as polygon, and so on. So yeah, I hope this gives you an idea of how the process APIs requests are structured, how you can use the examples to explore them, and where to add something if you want to change something. The next, we have finished this part, and we can now go under the third part, where we are going to introduce the Python. For this, I'm going to go into my other browser, where I have the Sentinel Hub Processing API services open. You can get this. I'm going to show you where you can get all of this. If you go to SentinelHubPy to this URL, if you just Google Sentinel Hub Python documentation, you're going to get this whole documentation, which has everything explained for you. It has the examples. For example, this is a notebook that we have open, and many more things. Then there is also a Sentinel Hub GitHub, where you can search for Sentinel Hub Py, and you can then clone this repository and work with it. And here under examples, you have this processing API request notebook that you can download, and also the utils py file is important here because it has some stored in that the notebook is using. Okay, and now we can go back to our notebook. So in Python, we need to authenticate as well. So this code over here lets the system know whether you are authorized, and the structure as it is over here makes it possible for the user to import the credentials over here, or to put them into a separate configuration file. We're later going to take a look at the different way to structure this that only lets you use it like this, that expects you to import it into the notebook every time. So first, let's authenticate our notebook. Go to dashboard. Let's grab the ID that we have created, pop it in. Then let's open our text and pop this in. Okay, now we're going to run this and run this cell. And here the imports come into play. So in Python, you have to, of course, import all of the dependencies and everything that you're going to be working with. Here we are importing NumPy. We're importing matplotlib. This is because the notebook is going to use this further down. Very important is to import, after you have, of course, Sentinel Hub installed, to import from Sentinel Hub a MIME type, which is a format, CRS bounding box, SentinelHubRequest, download client if you want to download stuff, data collection you will need, and other ones. And then we are importing from utils. This is that file that I showed you inside that has this plot image defined in the file. You could also define it over here if you wanted to. Okay, the notebook is working on the Betsiboka River Delta, as it seems. And over here, it defines the coordinates. It just poses this variable and an array of coordinates. And then over here we have you can name it anything, and then it calls this bounding box object, which uses the coordinates which are read from being defined over here. They could, of course, this array could also be imported over here, and also the coordinate systems, because coordinates and coordinate systems go together. And then this one is very handy, the Betsiboka size named here. This is a very handy function, bounding box 2 dimensions, which calculates the size in pixels of the image that you are going to request in advance, based on the coordinates and based on the resolution. The resolution over here was set up here, and it was just referenced in here. This is very cool because you can just specify the coordinates and the resolution, and you do not have to figure out what is the ratio of the width and height pixels that you want to import. You can just then write the Betsiboka size, and everything will be done for you. Okay, let's not forget to run any important cells. So here, this prints you that the image will be of 60-meter resolution, and it is going to be in this size of pixels. So now we're going to make a true caller request of this Betsiboka River, and here is the request in Python form. First, we have the eval script, which just returns the true color. As you can see, it has function setup, function evaluate pixel, and then down here the request is defined. So this request true color can be named anything, and then the Sentinel Hub request lets the system know that you are using a process API. And then we have the eval script, and it is called in over here, from here. Then we have input data, which has a data collection of Sentinel-2 L1C. This is equivalent to the type that we saw before. It lets the system know which data collection you're using. In this case, it's Sentinel-2 L1C. The time interval is structured like this. In the parentheses, separated by comma, this is a before date, and this is a to date. And then on the responses, we have the identifier, and we have the MIME type .png, which is a format. Then we have the bounding box, and we are calling in what we defined up here. Then we have the size, where we are calling in what we defined up here and what was calculated here. And then this config just references this what the config is, this code, and checks whether you are in fact authorized. Okay, so let's send the request now. Now, sending the request in Python doing this in Python doesn't actually send the request, but it just prepares the request. You have to also get data. So you define a new variable, and then you reference the name of your request and say get data. This is now actually going to send the request, and it is going to get an array of images. And then down here, when you reference a new variable of image, and then you say that you want the first available image of this get data. Now, the last thing that we want to do is actually plot an image. Plot an image means is a way to visualize an image, because this now only tells the system which one we want, but not yet that we actually want it visualized, which is done with this. We are referencing, of course, this, and then this factor over here, basically, it turns the image that is in unsigned integer 8 form from 0 to 255, it turns it into a range of values of 0 to 1. It does that by dividing it with 255, and this 3.5 is a multiplication for brightness. Now, if we run this as well, okay, we get an image. Yeah, so this one tells us which format it is. The format comes from the eval script, always using sample type auto if not specified otherwise. Okay, so this is the main part. Now, I encourage you to take a look at this notebook yourself. There is a lot more that you can do. For example, you will learn how to add the cloud data, how to say that you want the image with the least cloud coverage by adding this mosaicing order over here, how to request all the bands, how to save data to your disk, how to use multiple responses, how to use a lot of other things that are very useful. Also some are referenced in our examples on our documentation. And now let's go to the last part, which I believe is very exciting. Here I have the notebook prepared, and this notebook is prepared so that you can import any request from in Python form from the request builder, and you will get an image. As you can see here, it is the minimum notebook. It has all the minimum things that it needs to produce an image. From Sentinel Hub, we have imported shconfig, a MIME type, it's a format, a coordinate system bounding box, SentinelHubRequest, and data collection. And then from utils, we also import the plot image. Here we have the credentials set up, and this is the other way in which we can set the credentials. It's a bit shorter, but it requires you to set the credentials into your notebook each time. And then at the end, we have the get image is going to be in the request builder request already. So we only need over here to get the first image of that array, and that just that code to visualize it. This is everything we need. And now we go to request builder. Okay, so now what I would like to do, I would like to check the NDVI of this area in Veneto region in Italy. I'm going to draw the bounding box over here. And I am interested in imagery on August 11th. As you can see, you can just write it in like that. It's very easy, or you can search by the date. Okay, I will leave it as a PNG. True color is okay for me. And I am now going to send this request. And okay, this is the image. And as you can, the true color image, as you can see, it is covered by clouds. So if I just calculate the NDVI, it's going to be covered by clouds and not very useful. So what we're going to do now is take a look at the datafusion script that made by Maxime. This is our collection of custom scripts found by customscript.sentinelhub.com. Also on GitHub, you can contribute to it. And we're going to go to datafusion. Here's a shortcut to that. And mapping crop NDVI with Sentinel-1 and Sentinel-2. So this is a script. As you can see, this is the same as we looked at, is a true color image of the area covered by clouds. And then this is the NDVI of Sentinel-2. And this is all red because the obviously vegetation, it was clouds here, so it's obstructed and the values are very low. It obstructs the information. And then after doing data fusion with Sentinel-1, this is the result that we got. So basically what the script does is it locates the clouds in a Sentinel-2 image and then returns the calculated NDVI for Sentinel-2 where the clouds are not present, and where the clouds are present, it returns the Sentinel-1 NDVI. Now we're going to scroll up, click on Show Script. We are going to grab this script and copy it. Then we will go into the request builder. We can first display what we have already in Python. Let's select sh.py over here. and the Python is going to be turned on. As you can see over here, we have some imports that we would need. Also, the credentials are set up. We are not going to need this because we already have all of this. So all you have to do each time is grab everything from the eval script down. And this is now this is the true color one. We are going to go over here and paste it in. I'm now going to run all of these cells. And the image is visualized. It's as simple as that. Okay, so let's go back to our request builder. Let's grab the script again. And we have to turn our data source to be datafusion first. Then we are going to paste in the eval script. And now the other important thing that we need to do is make sure that the IDs of the data sets in datafusion match these IDs in the function setup. It's the easiest to just grab it from the eval script and pop it up here. Otherwise, we would get an error. Okay. We already have it over here. You can see it's a script by Maxime. It is everything is already prepared. And now all we have to do is grab all of this as before, go into our notebook, and we are going to replace this by our datafusion script. And we are now going to run it again. And we have the datafusion script in Jupyter Notebook, just like that. This is everything I have prepared for you today. Thank you everyone for participating.
Thank you, Monia, and of course also thank you to Marian. Let's start with our questions and answers section. As said at the beginning, you can still write your question in the chat or even raise your hand to ask it out loud. So let's take care first of the questions which they were already stated during the presentation. The first question came from Angela, and she is asking if netCDF as output format is supported. And I can answer this one, Monia, if I may. It's not supported. We currently don't support this format yet, but we might if we get enough requests for it from our users. So I think the best place to start discussion about this is our forum. Then we have the second question from David, who is asking if we have a tutorial or guide, step-by-step guide about this webinar in our webpage. We don't have one step-by-step guide which would cover all together, but the parts of the webinar are spread and it can be found in our documentation, and you will be able to find the relevant links to particular parts in the recordings descriptions once we publish the recording on our YouTube channel. Then we have another question from Andrei. He's asking, using SentinelHubRequest, can you request and save all the images taken in time period? I can ask Matej, my colleague, for the answer. Thank you.
Hi everyone, Matej here. So SentinelHubRequest will always return us a single image, but we can combine using SentinelHubRequest with WF, so Web Feature Service request, from which we get all available dates, and then we create, for each date, we create SentinelHubRequest to download image for that date. So we have some examples in the documentation about this.
Thank you, Matej. Alex is also asking if there is a YouTube channel where we can watch the recording. Yes, the link will be shared with you. It's also shared on our webinar webpage, and it will be sent to you via email a couple of days after we finish the webinar. Then Jivan is also asking, for true color, you multiply values by 2.5 or 3.5 or 5. How do you choose this one?
Maybe I can jump in here.
Thank you, Anya.
For the true color, it's basically just based on the visual analysis of the result that you get by these factors. We somehow realized that 2.5 is doing fine for most of the areas, but it really depends on your use case. So if you want to focus on a specific area, then maybe some other factor would work better there. So I would just say, yeah, it's based on the visual analysis.
Suman is asking how can process Sentinel interferometry in Sentinel Hub.
That's currently not possible.
Ahmed is asking if there is an atmospheric and radiometric correction.
For the Sentinel-2, we have products on two levels, Sentinel-2 L1C and Sentinel-2 L2A. So level 2A would be with atmospheric correction. And then we also do offer the radiometric correction for Sentinel-1. Maybe Marco can tell us a bit more about that.
It's not supported now, but will be soon.
Thanks.
We got also another question from Camelia, and she's asking if it's possible to get some information for GHG emissions by using Sentinel Hub.
Basically for greenhouse gas emissions, you probably want to use S5P. So it has various bands which correspond to that. So you can get stuff like SO2, NO2, and whatnot.
So we got additional questions. Is there a possibility to process Sentinel-2 to surface reflectance? Maybe also question for Marco.
That's the level 2A products which were mentioned. So basically all the Sentinel-2 data can be on top of the atmosphere or on the bottom of the atmosphere, or in other words, surface level reflectance. So this is basically just the level 2A data.
Thank you. Then Alex has another question. He's asking if there is an academic or research plan for using the platform that is free of charge. So there is a Sentinel Hub account which you can apply for a trial period for 30 days. And after the 30 days expire, you can purchase one of the subscription packages which fits your needs best. But if you are conducting, in this case, like the question was stated, if you are conducting a research or if you are in a pre-commercial exploitation phase, we would like to invite you to check out also our Network of Resources program, which offers ESA-sponsored accounts and free access to high-resolution commercial data as well. And to learn more about this sponsorship program, you can visit either our webpage or you can also join us on our next webinar in January, which will cover the topic of Network of Resources sponsorship program. Then we have another question from Joan, if it's possible or easy to configure proxy when running it in Python. So maybe also a question from Matej.
Yes, Sentinel-HubPy package has a configuration file where base URLs are configured. And also for each data source, we have configured a base URL. So basically, if you want to redirect your request to your proxy, then you can change those and it should work.
Thank you, Matej. Then Olga is asking when Sentinel-6 data can be expected. Maybe Marco can tell us more about this?
Yeah, very funny. No promises. We haven't even gotten any data available, so can't say anything right now.
One more. Someone asked if digital elevation model of Sentinel Hub, what is the vertical accuracy?
For that, please check the documentation of the DM you're interested in.
Okay, thank you. So I think this brought us to the end of today's session. Like mentioned before, if you have additional questions, freely contact us via forum. We will be happy to attend your questions. And I would also like to invite you to our social media channels for more updates. Otherwise, thank you for joining us today. It was quite an interesting session altogether, and we hope to see you soon. Thank you very much and stay safe.